Hello, dear students. Today we are going to discuss about some portions in electrical safety. So first we discuss about AC shock versus DC shock. The previous presentations we have discussed about the different parameters which affect the shock. So shock can be from AC source or also from DC source. Shock from AC currents, AC has a frequency. In our country, the frequency is 50 hertz. The frequency disturbs the frequency of heart. As we know, the brain gives us signals to all our organs, including heart, through some minor voltage, and it got some frequency also. So, if our body got electric shock, the frequency of heart signals will be disturbed. The person touching the live conductor cannot move his muscles and is unable to get detached. The muscle of lung diaphragm get contracted and functioning of lungs get affected. So what is happening actually, suppose somebody is getting a shock, an AC shock, he cannot take his hand back, muscle control lost. And also in diaphragm also, lung diaphragm also contains a lot of muscles. So muscles contractions only result in inhaling and exhaling. So this will affect inhaling, so people cannot breathe. And also shock currents above certain magnitude may affect the stoppage of heart, and thereby the blood flow to the brain will stop, and that will result in a brain. A normal frequency of heartbeat is 70 cycles per second, and a normal respiration is for a healthy man it is 12 to 16 cycles per minute. So AC supply frequency is 50 cycles per second, that is 350 into 60, 3000 cycles per minute. So 50 hertz current will be very dangerous. This is not will not happen in DC shock because DC does not have any frequency. DC frequency is zero. With the DC shock, this frequency of the heart signal will not be disturbed. So we can say AC shock is much severe than the DC shock. That from the table itself we can see. For take an example of number 6, shock, painful and severe muscular contraction and breathing difficulty. For this effect, DC for men, DC 90 milliampere is required. For AC for men, it is only 23 milliampere is required. For the same effect, AC require less current, so we can say this AC is more dangerous. And next topic we see lightning. As we know, the atmosphere contains a lot of particles. The particles will have a friction with clouds, and the cloud get charge. And this charge, um, yeah, the electric discharge, lightning is nothing but an electric discharge between the cloud and earth, or between the clouds, two clouds, or between a charge center of the same cloud. So we can say it is between cloud and earth, from cloud to earth, through maybe a media called maybe a mobile tower, maybe a tall tree, or maybe a building. So from cloud to earth, or between two clouds, one positively charged cloud, the negatively charged cloud, between two clouds, or between the charge centers of the same cloud itself, there will be discharge. So this is called the lightning. We can classify the lightning into two types, that is direct stroke and indirect stroke. Direct stroke, the lightning discharge is directly from the cloud to the subject equipment, maybe an overhead line, and in the indirect stroke result from electrostatically induced charges on the conductors due to the presence of charge cloud. The direct strokes occurs from cloud to transmission line. The causes may be over voltage surges on tower, or flashover that can occur across the insulators from conductors. What are the protective measures can be utilized here is overhead shielding conductors, above face conductors, surge arresters, lightning mass in substation, lightning rods on tall building, grounding mat, insulation, coordination in substation, neutral. Indirect lightning surges produced by charged cloud moving over the transmission line. Severity is less than that of direct shock. And preventive measures against shocks from lightning. So the preventive measure, first we have to dedicate overhead earth shielding wires, lightning rods in the building, surge arresters. Different types of surge arresters are there, or lightning arresters. It is also called lightning arresters. Prevention of shock, that is body structures must be earthing is very important to prevent the shock. Maybe if you are doing some maintenance, we have to use proper PP, especially electrically insulated clouds. Live line maintenance must be thoroughly, by using standard equipments, or try to avoid live line maintenance, try to do the maintenance in offline. Safety precautions against contact shock and flash shocks are design of electrical plant installation involving several equipments, earthing system and civil works, general safety precaution, erection of plant and equipment, testing and commissioning of plant or equipment, operation. And for small residential building, safety precautions can be listed do's and don'ts. For large electrical installations, systematic safety management system must be established. Safety precautions in LV installation, mainly in residential building. Switch off the main switch, take out fuse holders before carrying out any repair work. Online, we should not use any repair work. We have to switch off, or main switch should be off. After that only we have to use. Use shock-proof appliances. Mainly, if we can use ELCB, miniature circuit breaker has to be used. Do not immersion water heater. You do not use immersion water heater, exposed room heaters. These all are very dangerous. Replace defective switches immediately. Loose connected switches immediately. All these safety precautions in electrical plant, mainly the electrical installation, maintenance of electrical installation, mainly work permit, access to work, entry passes, materials. Installation, commissioning and maintenance work should be carried out with written permission. That is nothing but a permit card. Steps for safety are isolation of the part from live parts, danger plates and safety notices. Neighboring switches must be locked open to avoid third person. And the earthing, the equipment should be earthed and the proper tools should be used. Electricians should be well trained, certified electricians. First aid should be available. Follow the rules and use the proper shoes, safety belts, helmets, etc. Do not use wet cloths. It's very dangerous because wet in our body. In the previous presentation itself, we have discussed the during the wet condition, the body resistance is decreased to 100 ohm. Earlier, it was up to 1 lakh ohm. 1 lakh ohm is reduced to 100 or 1000 ohm in a wet condition. So we have to avoid that type of things. Live line working should be carried out only when the shutdown is not permissible and with Faraday cage or any well equipped equipments. Aim of safety precaution, not even a single person should get injured. Types of fault in electrical power system are electrical machine networks equipments are often subjected to various types of faults, such as sudden increase in current, sudden increase in voltage. So this fault can occur due to many reasons. One is maybe lightning, maybe wind, tree falling of lines, apparatus failures, all these things. Fault of an electric power system can be defined any abnormal condition of the system that involves the electrical failure of the equipment such as transformer, generators, bus bar, circuit breakers. Once the fault occurs in the circuit or device, voltage or current values deviate from the normal ranges. So the value of the normal voltage, suppose it is 11 kV, it is increased from the normal value, then we can say that is a there is a fault. This results in interruption of the normal operation of the network, failure of equipments, electrical. Now we can classify the faults into two, that is open circuit fault and short. Open circuit fault occur due to the failure of one or more conductors. The conductors may break. This is what happens. One phase is braked, two phase may be braked, and three phase is break or three phase is open. Causes may be broken conductors and malfunction circuit breaker is in one or more phases. Effects are abnormal operation, may be danger to personnel as well as animals. Short circuit can be defined an abnormal connection of very low impedance between 2 points. If 2 points with a very low resistance is connected, it can create a short circuit fault. And uh, faults are caused due to the insulation failure between the phase conductors or between earth and the phase conductor. These are the different types of short circuit fault. Now, three phase clear of earth, three phases are touching, so it is also called symmetrical fault. And three phases connected to earth and face to face, or it is also called line to line fault. Maybe it is single phase to earth, one line is connecting to earth, and two phases, double line to earth, and face to face plus single phase to earth. These are the possible types of short circuit. The causes of short circuits may be include internal breakdown of transmission line or maybe insulation failure, all these things. Or external effects including overloading, all these things are the external. Arcing of fault can lead to fire or explosion. Abnormal currents cause equipments to get overheated. All these are the effects. And maybe power flow is severely restricted or even completely blocked for as the part of short circuit, and continuity of supply cannot be maintained. Electric shock first aid treatment. First thing is that high voltage electricity has the ability to jump or arc, so we should not close at a distance of 18 meters or over. Suppose when you are in a car, a transmission line is fall down in a car, you have to come out from the car in a very safe manner. We should not take one step from the car, one leg in the ground and one leg in the car. There is a potential difference can be created and it create a shock. So there is a separate procedure. If suppose unless otherwise there is no much problem, please be in the car itself. Low voltage faced with such a casualty, attempt to turn the power off at the mains. Action take, insulate yourself from the ground with the books or any type of items, rubber or newspapers, something like that. First of all, we have to assess the level of response to the victim, whether victim is alive or not. Say, ask, hello, can you hear me? Like that we have to ask. Ask in both the casualties' ears to open their eyes. Pinch on earlobe, or whether we just want to assure that whether this person is alive or not, or response is there or not. Call for help, call for ambulance. Next thing is that airway and breathing. For unresponsive casualty, open the airway and look in the mouth. Ensure there are no obvious obstructions. Inside the mouth, there is any obstruction is there. You have to clear it. Open the airway, lifting the chin and tilting the head back. If the neck spinal injury is suspected, put one hand on the stomach to feel if it rises and falls. And assess the breathing. Look for the rise and fall of the chest. Listen for sounds of breathing. Then only we have to start the CPR. If the person is breathing, you should not start CPR. CPR is nothing but cardiopulmonary resuscitation. First step in the CPR is casualty is in from flat surface. First of all, the casualty, the person has to be in lay down in a flat surface. Place your hands on the top of the other in the center of casualty's chest and compress the chest 30 times at a rate of 100 compression. 30 times at a rate of 100 compressions per minute. Compressions, and we have to at least we have to deep will be around 2 inches, that is 4 to 5 centimeters. After 30 compression, open the airway again using the head tilt and chin lift, and we have to breathe again. There is no response from the casualty. We have to again repeat the things. Remove your mouth to side and let chest fall. and repeat the thing for so many times, and at least up to the hospital is reached. Until the casualty shows signs of recovery or emergency services or up to the hospital reach. Thereby, the function of this CPR can be, the blood flow. It is nothing but the function of heart we are artificially doing. So the blood flow to the brain can be maintained. So brain cells will not damage. So brain death can be avoided by using the CPR. And after reaching the hospital, they will give electric shock. So once electric shock is given, there may be 60% chance is there. If the person is very healthy, there is a chance of restart of heart. If his heart restarts, he will live. He will live. And if suppose heart fails to restart after the electric shock, we cannot. We are helpless. The burns exposure to electricity can cause burns to the skin and in severe cases internal organs. So first degree, second degree, third degree burns can occur. Response casualties: cool burn for a minimum 10 minutes under cold water, and do not apply any adhesive dressings. Remove damaged skin. Apply ointments. All these type of things we should know. Casualties with no apparent injury. If no injury is present and the casualty appears well, take the casualty to hospital and the necessary. Thank you. Thank you so much.